Let's start things off with a little quick draw exercise. If it was graded, it would be considered a quiz, but this is just so you can feel how smart you are. What is the present value of $1,000 18 years from now, paid 18 years from now, if inflation is 2.8%. Okay, so calculate the, just using the equations here, not the table method, but flip to the first page of the equation packet and find the right equation and use it to find the present value of $1,000. $1,000 is going to come to you in 18 years. So you want to know how much is it worth in today's money. When you finish the first one, move on to the second. Don't look if you haven't finished working it yet. Okay, so you'll know in your heart if you would have passed the quiz. You would have got it right. You get both of those right and you're on track. You're doing all right. Things are going to be okay. If you didn't get them right, I think you need to study the tables, the equations, read the book a little bit more. And we've got an exam 48 hours from right now. Do you have a question?
There's a formula for the lesson that was in the book.
Okay.
It's the nth root of future over present value. It's the nth root of future.
Nth root of future over present value.
Minus 1.
Minus 1, that's exactly what this is.
Well, yeah, I know. I just said in the book it's straight.
Okay. Having just a few of these general equations can be applied in lots of different situations. So any questions on this? Let me give you the notes for today. Was that Josh that called you?
Yeah, it's over.
He better be. Bennett.
So we have to write all this down on the test.
What do you mean?
You can't use this on the test.
You can use that
I
on
thought
the
you wanted
test.
us to write it down.
No, I said like
Other
a dozen
formulas.
times. The equation packet, you can put that in your handbook of notes. What you can't have is the book. And so if there's anything in the book that isn't in here, or your homework, or an in-class exercise, then that's what you need to write down. And so I hope that by saying that, what I'll have you do is review what's in the book, and review what you've used in the book, and whether it's in. By the way, this packet of equations here, this is the equations that you'll use if you're an engineer when you take the engineering licensing exam. This is part of the supplied reference for the fundamentals of engineering exam. And so it's really beneficial for you to start to get acquainted with where equations are and what the format looks like before you take that licensing exam. And so what I do is I have this licensing exam handout be the equation packet for the classes that I teach, just so students are forced to get acquainted with it. Other question?
Yeah, like on some of the homework problems I took and copied the questions out, right? To a Word document, so I have them for the test out of the book.
So you're basically saying you want to have the book, even though I said the book's not allowed?
No, I mean like the homework questions, like yeah, we've got the answers, but we don't have the questions to the answers.
Okay. You could if you wrote down the question. So I mean, I guess that's about the same thing, right? You're saying you're writing down the problem statements. So I guess that's fine. Friday. Homework number 4 is due, and we'll have 80 minutes for that midterm, and then we'll talk about the project. Today, let me get your homework number 3. I'm just delighted to grade that. I love grading. I don't get to do enough of it. Normally I have too many students in any given class to grade all the work, and so there will be a grader. But this semester I get to do it myself. So I'm counting myself fortunate. Thank you. Yes, you have to memorize lots of things, like how to solve the problems, the meaning of terminology, no equations, but I mean, it depends on what memorize means. You know, like you have to memorize processes and problem solving strategies.
We're learning outcomes and domains of first year seminar, stuff like that.
You don't have to know the first year seminar learning domains and outcomes. No, not for this class. He's saying that because I made them memorize stuff in first year seminar. A list. But no, not this time around. Other questions? All right. Well, we've done our little quick draw exercise. Let's review goal seek. Please grab a tablet or fire up your computer. This is a really important tool that I want to make sure is firmly lodged in your memory. And so what we're going to do is recreate the process needed to find what interest rate makes those two cash flows equivalent. So from the in-class exercise yesterday, you could either get 70 million now or 4 million now and then 29 more payments of 4 million. And so by doing that, the lotto agency is assuming some sort of an interest rate. And let's calculate what that interest rate is that makes those two cash flows equal. And the easiest way to do it is by setting up a goal seek analysis. All right? So there's lots of good skills in that. For example, dragging down numbers so you don't have to type in all 0 through 29. And let's do it the formula method rather than PV. We're going to do it the formula method. So use the actual equation that uses I and N and all that sort of stuff from the equation here as you set up your columns. Sometimes it's easy to solve Excel problems when we have someone showing us what the column should be, but I want to just see if you can figure it out on your own. I bet you can. I bet everyone can. Okay, so we are comparing
Some of all those. What is on that? Yep. Kind of the some of the same thing. Oh, you'll do something. What did you do here? Then you subtract out another. Okay. Right there. They don't be seeing one would have been. Alright, we're gonna set this cell to 0
Yeah, I understand that part.
Okay, so on this in-class exercise, the first question is it saying, why is it that a higher interest rate gives you a lower present value? So look what happens. I've got the present value of that cash flow right here. This is how much you get depending on what the interest rate is. So if the interest rate is 4.2%, the present value of it is 70 million. But what if the interest rate is 6%? The present value goes down. So how would you respond to someone who's confused about the fact that the amount, the value of the amount gets lower as interest rate increases? If it's 10% interest, you only get $40 million. Only. You only get $40 million. But if the interest rate is 0.05, 64 million. So explain to the person who's confused why a high interest rate, in this case, makes the present value of the payout lower. How would you explain that to someone who's confused? That's what I'm asking in the first part of the in-class exercise.
What are the like first?
That's not right.
Okay. Well, this is an annual series, but what you've done is you've applied it to every row. And so what it thinks is that there's an annual series with 4 years, another annual series with 5 years, and so there's all these annual series. Really, since you're doing it to each individual row, you're saying, take this future amount to the present, take this future amount to the present. So it's really a defined P given F.
Okay, Dr. Wade, take a look.
Just one second. So now, this is, got all the cash flows here. Hospital, all the way to 29 there. And then we did some of it down there, and we also did the sum of here. Okay, so now you should have the difference between the 70 and that. Because you're going to try and change the interest rate so that the difference is the same. So that there's no difference, right? So you're almost there. You've set it up. This is not what you need to do is you need to add up all of those. So you want to know the sum of the present value. And change the interest rate so that the sum of the present value is equal to the 70 million. That yourself, or else you're not going to pass the exam.
You have a question? Do we work this on the computer or work this on the second one?
Use the table lookup method. That's the table.
How are you supposed to look at it?
You may have it in the book.
Yeah, I thought that I updated that.
Anybody have the textbook handy? I think the textbook has a 5%. Here's one.
Yes. I'll go make a photocopy of this.
Oh, it's very back, the tables in the
Yeah,
back.
yeah. There isn't a 5% table in the handout I gave you, but there is in the book. So I'll make a photocopy of the 5% table.
I'll be right back.
Who needs the 5% table? You don't have a vote? Finish the, where have you got the difference between, where's the sum of the present value? Okay. The difference of that and the other sum is here. Is what is analysis changing behind? You said that I'll change that. Okay, good. So for Friday, you have the table there. That's sort of that in how it's just yourself. I put the table right there. I want to equip you with an example that may help you solve some of these in-class exercise problems. So you can keep working if you feel confident. If you'd like to see an example of a multi-step problem, let me show you that. Okay, so how much should be deposited each year for 10 years if you want to withdraw a lump sum of $5,000 at the end of year 11 and make annual withdrawals of $500 for 5 years starting at the end of the 15th year? So this is a pretty complex one. The first thing we always do in problems like this is set up the cash flow diagram. And so here's what the cash flow diagram is going to look like. Okay, here's 0. And we want to deposit for 10 years. So 1, 2, this is year 10. And then in year 11, we want to withdraw a lump sum of 5,000. And then in year 15, we'll take out 500.
Are you continually depositing after a month?
No. Okay, the only deposits that we know about is each year for 10 years, and we don't know the amount. We want to withdraw $5,000 at the end of year 11, and annual withdrawals for 5 years of $500 starting at the end of the 15th year. So 1, 2, 3, 4, 5. Okay, so this is a multi-step problem. We can't take this all to the present in one step. And so my strategy is, first, I'm going to take the, so we don't know that amount. So my strategy is, first, I'm going to take the annual series here to year 14, and then from year 14 to 0. Then I'm going to take this from year 11 to year 0. And so then I'll know the total money back to me. So this is money, this is like money out, this is money in to my pocket. So I'm going to get money into my pocket in years 11 and then 15 through 16, 17, 18, 19. So I'm going to take all this to 14. Then I'm going to take 14 to 0. I'm going to take year 11 to 0. And then all the money at 0, I'm going to spread out as an annual series to year 10. That's going to be the outline of the solution here. And so what I would do first of all is find P given an A, 6% N equals 5, which is 4.2124. And that is multiplied by the $500. And so that is 2106.20 at year 14. So what I've done is I've converted this annual series here, I've taken it to year 14. So I'm going to draw what it is now. So I move that to this. And I found that its equivalent is 210620. And so now I'm going to take that 210620 from year 14 to year 0. Okay, so then I'm going to do find the present given a future at 6%, n equals 14. So the factor there is 0.4423 times the 210620, and that gives me 931.57 at year 0. So now I've moved, this was getting all of that to there. Now I'm going to move this to year 0, and it is equivalent to 931.57. So I made a couple of jumps there, showing just the techniques with the multi-step problem. So next, I want to take that 5,000 from year 11 to 0. So that is a find the present given some future amount, 6%, n equals 11. And so the factor there is 0.5268 times 5,000. And that gives me 2634 at year 0. Okay, so I'm taking the 5,000 to year 0, and that amount was 2634. And so the sum at present is the 931.57 plus 2634. So it is 3565.57. So now I know what's going to be coming back to me, and in present terms. So now I'm going to take that present amount, spread it out over an annual series to find out how much I have to deposit. In other words, if I took this much out now, and the interest rate is 6%, how much I would have to pay every year for 10 years to be equivalent. So the last part is I'm doing find the A given a P for 6% with n equals 10. And the factor there is 0.1359. So I'm going to multiply it by the 3565.57, and that is 484.56. So that's how much I have to pay every year, 484.56, in order to make this whole cash flow equivalent at 6%. The biggest mistake that students make in problems like this is not drawing a cash flow diagram. And the second most common mistake is interpreting the cash flow diagram wrong from the descriptions. So read carefully, force yourself to make a cash flow diagram, and the strategy will come naturally. Once you can see it laid out before you, you'll think, well, let's see, here's an annual series. I can collapse that down to a single value, then I can take that single value from the future to the present. Here's some future value, I'll take to the present. Now I've got an unknown A, I'll take it from the present, spread it out over the unknown A. It'll all sort of spiral into control once you have a good cash flow diagram. Question, Ellen?
I was just want to see number 2.
Sure. Yeah.
Quite all. So one of those.
didn't draw a cash flow diagram. That's the number one mistake. You can't, you have to have a cash flow diagram or, I can't really see where your calculations went wrong.
I don't even know what I did.
Draw a cash flow diagram.
You draw a cash flow diagram.
Okay, well.
Should that be to the 8?
Well, first of all, you're paying 50,000, so it's down. Yes, there is an annual series there that goes through year 9. So,
Oh, it should be the 9?
well, what does it say in the bond statement? There is,
See, I thought it was
for 8
3.
years.
I thought it was 3 years.
Well, you have to count the number of errors. 1, 2, 3, 4, 5, 6, 7, 8. You got 1, 2, 3, 4, 5, 6, 7, 8, 9.
Let me see.
Okay.
It's cash flow.
Right, these monthly 50s are on second year. For 8 years, you withdraw money, correct? Yes. Okay, then 20 years, you want to have 20,000. Oh, 25,000.
Other than that, you got it. Okay. Anybody else need the in-class exercise? I've given it to you. You're far too patient. You should have let me know. Sorry about that. We've already talked about gradients. Yeah.
So you use your we all the way down there for you.
Keep my computer plugged in. There's my little trouble. Okay.
Alright, it's bad enough on APD.
Feel free to take a quick break if you need to. We're just going to keep working through today. It's going to be somewhat ill-structured. Just going to go through examples and things. write the answers to the in-class exercise over here on the side so you can know whether you've got it right.
It's no fun.
One last thing is that you said now you're going to spread it from here into an A, right? But there's a gap here there. To go from a B to an A, it has to be the next year next to it. So you need to move the 4,000 from year 0 to year 1. And then start. See what I'm saying? The form of an annual series is that it starts the very next period.
So did that allocate credit?
You need to go to 1.
I think I'm just like, well, you need all that stuff.
Well, you need to draw cash flow there.
How many is this one here? I think they're pretty
So what's your strategy? You've got a cash flow diagram there. That's correct. It's a good cash flow diagram. What does that say? Is that 9 or is that 8? Eight are starting in the second.
Yes.
It's not in the first year, it's in the second. It's going to go 2 through 9. So 3 sides for strategy as well. You're going to convert that future amount to the present. All right.
Yes.
This is the present. This is the present. This is subtract the 50. So you're going to find whatever's left. One problem with it is that a P to A goes to the very next year. Remember, you've got a gap. There's no payment in year 1. It's happening in year 1. So you're going to have to move from present to year 1. Right? So
Well, I have one.
Good. I think it's better to move it to the present.
Move this all the way to birth.
I mean, I don't think there's any advantage in moving it to year 9.
Well, I see, if it was that, they started at the first year, it'd be there.
There is a solution whereby you could move it to year 9. But I think the simplest approach is to move it to 0. If your plan was to move it to year 9 and then distribute it back doing a F to A, that would be a component. There is a way to solve it that way, but there's going to be a few other pieces too.
You can do that if you want. Let me try it. You can try it first.
Several different ways to solve this Excel problem. Let me show you one of them.
That projector just seems like it's getting dimmer and dimmer each day. So she makes some deposit here. We don't know exactly how much it has to be. What we know is that at the end of year 10, we want her to have 25,000. And so each year it has compounded 4% more. And so it's 10,000, and the formula that I'm doing is the year previous times 1.04. And I can drag that down so that this is a perfect kind of problem to do a goal seek on. What I want is the difference to be 0 by changing the initial deposit amount. And that tells me how much she'd have to deposit if there's annual compounding. And then we can solve that also for daily compounding. So it would be day. So maybe if she puts in, start off with some value, we don't know exactly how much it's going to be, she needs to make as a deposit. For 10 years, there's 365 times 10, so we're going to have to go down really far, 3650. All of a sudden, Excel starts going fast. Close. How many days? And in this one, I is 0.04.
this is how much you have to deposit if it's daily compounding rather than annual. So sort of the tricky thing here is that, I'll show it on the annual version. Look at the formula, is that each row is just the row above it times 1.04, so that it's compounding a single year at a time. And so what we're looking at is the balance in the account at the end of each year. So at the end of the year one, the balance in the account is going to be 4% higher than when she made the deposit. And so at the end of each year, it's grown by another 4%. That's the Excel demo I wanted to show you there.
Did you use the goal seeker to get that?
Yeah, I did. I used the goal seek. The way that you verify the solution is you're looking for the present value. When you add up all of the present values, the sum of them should be equal to 0. And so that verifies that this is done correctly, because, I mean, $5.96 is basically 0. What it means is that you put in the 50,000 and then you make all these deposits, and then withdrawals, you're getting the money back. And when you make that final withdrawal, there's nothing left in terms of the present value. So all the cash flows balance out. The net present value of this cash flow is equal to 0. And that's how you verify that you've got the right amount for all of these years. This is the verification of what we've done before. So use the same approach to verify problem 3, that you solved problem 3 correctly. You find the present value of each of the years, and if it all balances, then I think in problem 3 it was asking how much would be left over. And so you should see that there is a certain amount left over. And you could verify problem 3 in terms of future value rather than present value. That would maybe be even more immediate a comparison to how they're asking the question, because they're saying when you make the withdrawal in year 10, how much is left in year 10? So you can prove that you've done it right a couple of ways, taking everything to the present, taking everything to the future. So attempt that, and I'll put a solution up once you've had a chance to do it. You will be free to go. So verifying number 3 with Excel, if we want to use the same approach that I just demonstrated a few minutes before, you put in your cash flow, you determine. In year 10, though, we've got the $5,000 withdrawal and the amount that when we did the manual way, we found that what was left was $21,102. So we also put that in because it's available for withdrawal. So we find the present value of all those amounts, and then you sum up the present value, and it should be equal to 0. The other method is a little bit more tricky, but yields a pretty nice result. So take a pause on what you're working on, because I'd like you to see this method in play. This may help you on the project being able to do it this way. The alternate way to verify that problem is think in terms of a deposit, how much the deposit is in each of the years. So this is the same cash flow that we had before, but then we want to think in terms of how much is in that account right now, so the account balance. In year 0, it's just whatever it was. But then look at the formula that I've got for the rest of these. I'm saying the account balance is however much was in there the previous year. That's my laser pointer. How much ever was in there the previous year, so year 0 times the interest rate. So 1 plus the interest rate, in this case it was 6%, I think. And then you add whatever the deposit was. And so it is the previous balance plus the interest that's making plus the deposit amount. And so you'll see that in each of these columns, like here, it's 16,000 because it was this much plus the interest that was made. So that's why it's 1 plus the interest that was made and the deposit amount from that year. And so in each row, we've got the account balance. And so this 21,101, that was how much was available for withdrawal, even after the $5,000 withdrawal that was made in year 10. So this is just a second way to verify your manual solution, is by thinking in terms of what would be the account statement that they receive in the mail at the end of each year. And so, again, the method there is that the balance is however much was in the previous year's balance, this times 1 plus the interest, then adding whether it's a deposit or a withdrawal. In this case, it was a withdrawal, so you're subtracting 5,000. So 24,624, interest up, it's going to be maybe around more than that because of the interest, and then subtract the 5,000, and that tells you how much is left. So that's just a secondary way of proving it. So we're out of time, and in fact, I've kept you 4 minutes late, so I'll give you back that time with interest tomorrow. Just looking at the announcement slides, I always like to close on that, so we're on the same page on when things are due. I'm going to be grading your assignments today. I'll hand them back to you tomorrow. And we're going to have our midterm on Friday morning, and then talk about the project. So let me know if you've got any questions on the homework as you start working on it. I handed that out last time, and I've got office hours after this, so just let me know.
Is there a way you can put that Excel back into the form?
Sure, yeah.